In the final lesson of the Headstart program, we looked at composite functions. So here's f of x and here is g of x. And what we're going to do is find h of x, which equals f of g of x. So this basically means that, well, let's write it out. What is f of g of x? We'll write out h of x equals f of, and g of x is this thing here. So it's f of x squared plus 3, which, remember, all that means is every time you see an x in the function, replace it with this thing here. So all we do is we write x squared plus 3. So that's writing this thing here where we see an x. And then you just rewrite the rest of the function. So that's x squared plus 5. Right, so h of x is a composite function because it's composed of this inside function, g of x, and f of x. Alright, so p of x is equal to g of f of x. So p of x is equal to g of, now f of x is the linear, x plus 2. That means everywhere where we see an x in g of x, we replace it with x plus 2. So we go x plus 2 all squared plus 3. So what we've done there is composed some functions. So the function h of x is said to be a composition f with g, and the notation that we sometimes see is this notation. So function h is a composition of f with g, or p of x is a composition of g with f. Okay. Now I tend to only see that notation in VCAR exams, but I'd become familiar with that. I think that's in the study design, so you just want to be all over that notation. So when we're composing function, there are some rules. The range of the inside function must fall within the domain of the outside function. Or to summarize the idea for the function above, the range of the function f must be a subset of the domain of the function g. Okay, so why is that a rule? Well, let's just check it out with this example and see why we need some rules to kind of oversee the composite functions process. So we've got f of x equals 2 take x, a linear, and g of x equals root x. And what I'm going to do is just quickly write down domain of, actually let's write out like so. So let's write f of x, g of x, and domain and range. Alright, so what's the domain of f of x is all reals because it's linear, and all reals for the range. G of x has a domain 0 to positive infinity because it's just the root x function, it's just that one there. And the range is also 0 to positive infinity. Alright, so now that we know that, we're going to find f of 6. Now f of 6 equals 2 take away 6 is negative 4. G of f of x, where x is equal to 6. G of f of 6 equals, now we know that f of 6 is negative 4. G of negative 4. Now g of negative 4, so g of x is this function here. So g of negative 4 will be the square root of negative 4 equals, oh no. Okay, so in maths methods we can't find the square root of a negative number. It's not real, so we don't proceed with it. So that means that this composition doesn't work because what f of x can do is send out values that g of x won't accept, i.e. f of x's range does not fall within the domain of g of x, and that's a problem. And that's really what this opening statement says. The range of the inside function must fall within the domain of the outside function, or that the range of the function must be a subset of the domain of the function you're trying to compose, make the composition with. Okay. All right. So the composition g with f could be made with a domain restriction of f of x. All right. So currently the domain of f of x is all real numbers, right? Now what we want is, for this composition to work, we want the range not to be all real numbers, we want it to be 0 to positive infinity, so that it fits within the domain of the outside function, the domain of g of x. So what I'm going to do to work out what that number is going to be is I'm going to go to take x must be greater than equal to 0. So f of x has got to be greater than or equal to 0. Now that's negative x is greater than or equal to negative 2, x less than or equal to 2. So that's the domain restriction, because if x is less than or equal to 2, then this composition is going to work. All right, so that's the restriction. Let's just write it out. So we'll do the composition now. So we'll say that g of f of x is equal to, so that's missing a bracket, equals root, and instead of x we'll write in 2 take x, but it's only going to work where x is less than or equal to 2. We can kind of see that intuitively, but it's good that mathematically that suggests that. Alright, note that the domain of the composite function g of f of x is simply the restricted domain of f of x. So once you have restricted the domain, which we did above, then it was going to be x less than or equal to 2, i.e. the domain of the composite function will be whatever the domain of f of x is. Alright, so let's just try and see why that makes sense as well. So here we've got two functions. What's the implied domain of f of x? 0 to positive infinity. And actually let's write it out in one of those tables again. So f of x, g of x, dom, and range. So f of x has an implied domain of 0 to positive infinity, a range of 0 to positive infinity. This one has a domain of all reals, and it's a parabola, so it's up 4 units. So 4 to positive infinity. So find h of x equals f of g of f of x. So h of x equals g of f of x, which is root x, which is x root x squared plus 4. So root x goes everywhere where I see an instance of that. Alright, now interesting scenario here. So here's my function, which typically you would do, you would say square root when squared is just x plus 4. Alright, now that means that I've got a linear function here as a result. So h of x is a linear function. You might be tempted to say where the domain, where x is an element of all real numbers, because that's linear. But in fact, the domain of this will be the restricted domain of f of x, or just the domain of f of x. So it's going to be 0 to positive infinity. Now you might be thinking, well, why is this linear function only true from 0 to positive infinity when I can see that it should be for all real numbers? And the reason is that this function here is based on this function here. It's got to be true for this and therefore true for this. Now the reason we can't do it is if we say h of -1, that's g of, and we'll put -1 into this, which is root -1. Now we can't find the square root of -1, so this is the oh no scenario. Alright, this is not real. So therefore, it's not possible to find h of -1, even though if you look at this linear, you might go, but like put it in that one. -1 plus 4 is 3. What's wrong with that? And the reason is that it's not true for this one, which is the step before it. Okay. Alright, so the domain of h, we just wrote it down here, but let's just write it again. 0 to positive infinity. It's not all real numbers. Okay, consider f of x equals root x and g of x equals 2x take 1. State which of f of g, or f with g or g with f, is defined. Alright, so we'll do that table. So f of x, g of x, dom and ran. F of x, 0 to positive infinity, 0 to positive infinity, reals, reals. Alright, let's test f of g of x first of all. So, is this going to be defined? So what we've got to check is whether what g of x will produce is a subset or falls within the domain of f of x. So we're going to check g of x's range, which is all real numbers, and consider whether it falls within the domain of f of x. And sadly, it doesn't. Because this one says, I produce all real numbers. And this one says, I only accept values between 0 and positive infinity. So that's a problem. This composition is not going to work, all right? Because it will produce things that it won't accept. Therefore, we say that it's not defined. We're going to say is not defined as domain, as the range of g, which is all real numbers, is not a subset of the domain of f, which is 0 to positive infinity. Right, so f of g of x is not going to work. Okay, so let's just test g of f of x. So obviously this is the one that works. So g of f of x. So what I'm going to do is check what f of x can produce, which is 0 to positive infinity, and what g of x will accept, which is all real numbers. So this produces only those values. This accepts everything, which means that the composition is going to work. So is defined as the range of f of x, which is 0 to positive infinity, is a subset of the domain of g, which is all reals. Alright, so for the composition that is defined, state the domain and rule. So let's get the composite function. So g of f of x is g of that, which is 2 root x take 1, where the domain is going to be the domain of the original inside function. So f of x is root x, where x is an element from 0 to positive infinity. Alrighty, for the very last problem. In general, f with g is not the same as g with f, but there is an interesting case. So we've got f of x equals that, g of x equals that. Find f of g of x and g of f of x on your calculator. What do you notice and why? Let's just do it by hand. So I'm going to do f of g of x. So g of x is this, x on 3 plus 2 on 3 equals 3 times take away 2, I think, is it? Yeah. Okay, so the 3 cancels out with those two, leaving us with x plus 2 take 2, which is x. Okay, so when I do f with g, the composition means that the function is x. Okay, now let's do g with f. So that's going to be jam 3x take 2 did I do that right? Yep. 3x over 3, take away 2 on 3 plus 2 on 3. They cancel out, giving us, funnily enough, x again. Okay, so here is the special case where f with g is equal to g with f. Now, why is this the case? Okay, so what do we notice? That they both result in x as a function, or g with f is the same as f with g. Now, why is this the case? Well, whenever this happens, you've got to know that these are inverses of each other. So what I'm going to do is just quickly invert that. Y equals 3x take 2, x equals 3y take 2, x plus 2 equals 3y, y equals x on 3 plus 2 on 3. So what you can see there is the inverse of this is this. So what happens basically is if you compose a function with its inverse function, it undoes what has been done, leaving you with this most simplest y equals x function. Right? It basically undoes itself, if you want to consider it like that. Alrighty, so the work from this exercise is those two things there. Good luck with your work over the summer, and good luck next year.